In today's video, we are going to talk about some of the methods that are offered in Pandas series and what to keep in mind while using these methods and how you can use them efficiently. And a series object has many attributes and methods that are useful for data analysis purposes. Even it might be in the context of data science, machine learning, or simple data analytics as well. And in general, the methods in Pandas series return a new instance of the object, but most of the methods have an in-place or a copy parameter available to them. So an in-place parameter will change the existing series object, whereas the copy parameter will give you a copy of the series object, and their default value tends to be false and true, and you can change them while operating on series objects as well. So before we move on towards our working example today, we start by importing pandas first, and then you see we have two examples here, songs_66 and songs_69, and these are influenced by Beatles, as you can see from the names of indexes, George, Ringo, John, Paul. And in the first song 66 we have 4 index values, 4 normal values, but one of them is none. And if we print it, we see the indexes and their values against it. The name is given counts, as you can see here, and we have the data type float. I'll just explain it to you why it's float, even though we have given integers, by seeing the contrast with song 69. So if you see here, we see a similar structure, but the data type is in 64. The difference here is because we have none value in one of our series, and it converted, or pandas converted it to NaN, hence float 64, because data type of NaN in pandas is float 64. Now let's start by iterating over a pandas series, how you can do that. So there are 3 options available to us. One is iteration over a series that just iterates over the value, similar to what you do for a Python list as well. So you can see it printed out all the 4 values that we have. Then similar to what you have in Python dictionaries, you can loop over index and value together at the same time using iteritems. So if you run it, you can see it prints index and value together. And then the third option is just getting the keys of the indexes, and if you print, you can see the keys. But just remember here, unlike the keys method of a Python dictionary, the result is ordered. So if you remember your original Pandas series object, so it is George, Ringo, John, and Paul. So you will also get George, Ringo, John, and Paul in the same order that you have in your Pandas series object. So now let's talk about overloaded operations. So the list that you see right now on the screen has overloaded operations contained in it, and they are all applicable to series objects. And the operations behave in a special way for pandas objects that might be different than other Python objects when you use them with these operations and how they respond. So let's start by looking at some common arithmetic operations. So the common arithmetic operations for a pandas series are overloaded to work with both scalars and other series objects. And addition with a scalar, assuming numeric values are there in the series, simply adds all the scalar values to that series, and this is called broadcasting. So let's see an example. So if you just add 2 to your song 66 object, you have added 2 to every individual value or element wise in that particular series. So here is an important note that you should always remember. Broadcasting is a pandas feature, and a normal list supports some of the operations that are listed in the overloaded operation list above, but not in the element wise manner, and the same way that the pandas objects do. So for example, when you multiply a Python list, let's say this, you see a new list with the elements repeated by the number of for the time that it's multiplied by. So here the list 1, 2 is multiplied 3 times, so you have 1, 2, 1, 2, 1, 2, 3 times. But that does not happen in pandas. So let's see another example of broadcasting, or rather overloaded operations, where I'm adding the 2 series objects, song 66 and song 69, and let's see what happens. So this first one is the result operation of these 2 additions, and these 2 are the original ones. So you can see for George it's 7 and 3, so it becomes 10. For John it's 18 and 11, so it becomes 29. For Paul it becomes 22 plus 9, 31. But since we have NaN for Ringo in song 66, it gives us NaN in the final result as well, irrespective of what is present in the other dictionary or other series object. So in this case, it can be a problematic situation because we don't want the count of Ringo songs to be NaN, because there was some count in one of the series and the other series did not have any. So to solve this issue, we use fill NA, which fills the null values or NaN values in the series object, and we do this by filling in null values with 0 in this case to see and get a proper answer. So yeah, and wait a second. So this is how we do it. We know that song 69 does not have any null value, so we will not add the fill NA operation here, but let's just see what happens. So now you can see the Ringo has 5 in it. The other arithmetic operations for subtraction, multiplication and division work the same. Let's look at one of the comparison operators. So let's look at greater than or equal to in action. So what we do here is we just fill the null values with 0 in both cases, even though we know we don't need to do it in song 69, and then we compare these values against each other. So let's see. So just for comparison, you can see George, I added the sort index to sort the index in orders to better compare. So George here is 3 in 66 and 7 in 69, so it becomes true. Same applies for John, it's lower in 66, and for Paul as well, and for Ringo as well. So we get all true values in our comparison. So now let's talk about getting and setting values. The series object allows for access to values by index operations with lock and ilock. I created a video about it in the past. I'll tag it in the description as well, or you can check it on the top right of your screen now. And these methods are also used for getting and setting values, but you can use some other operations or some other ways to get and set values as well. So similar to a Python list, you can, or a dictionary, you can do this indexing where you know the index and then you just put it and you can check the value. You can use the get method as well. So if it searches for the index, if it finds, then it will print that value, otherwise it will print missing. So if we see, we don't have Fred in our song 66 series, so it prints missing. You can also use a dotted attribute access, but remember that this access is only supported for valid attribute names where there is no conflict with pre-existing series attributes, and the index name do not contain any spaces. If it contains any spaces, you need to use this way only. So you can get the same value as well. And there is a note to be remembered here. So these all valid attribute names are names that begin with letters and contain alphanumerics or underscores, similar to what you have in variable naming for Python. If an index name contains spaces, as I said, you do not use dotted attribute access to read it. You use the index access, as you can see here. So now let's talk about setting values. So you can set values like this by the index access or by the dotted access as well, and it will work the same. Just remember the same conditions that I talked to you just a few seconds ago. Dotted access don't work with spaced attribute names. So now let's talk about the next set of methods which are available in resetting of an index. So depending on the context of the problem, it can be useful to change the values of the index themselves. Now we'll have a look at few of the methods that are used to reset the index, change which index labels are present, and rename the labels of those indexes as well. The first method is called reset index, and it will reset the index to monotonically increasing integers starting from 0. And by default, this reset index methods returns a new data frame, not a series, and it moves the current index values to a column name index. So let's see it in action. So this is our original series where these are our index values and these are the actual values of these indices. And now when we apply a series reset index to this series, we can see that the index becomes a column and the name becomes the column name for the values, and we have a new index that is monotonically starting from 0. So if you want to get a series output only, not a data frame output, what you can do is you can pass drop equal to true. So you can pass the true value to the parameter drop in reset index, and what it will do is it will, as the name suggests, drop the index column and you will get a series object. And you can do one more thing. If you want your series to have a specific index order, you can pass a list in the reindex method, and these new index values will have a value of the optional parameter fill NA or fill value, which is default to NaN. So if you see here, so it has a fill value parameter that is available, so its default value is NaN. So if I apply this reindex to this, and you can see this was the original series object, but when we applied reindexing, the only common index present was George. So it only took the value of George, otherwise it added the fill value default NaN to these 3 other indexes. So let's say if I change the fill value to, let's say, -1. So let's see what happens. You can see all this default values changed to -1 for all the indexes that it could not find. Alternatively, you can also rename some of the indexes with the rename method, and this method either accepts a dictionary. So as you can see here, where the key is the older index name and the value is the new index name, and you can also apply a method as well with the lambda function. So let's see both of them in action. So first, when you apply the rename, so Ringo changes to Richard, and let's say if we apply a lambda method, so song66 dot rename, so now you can see all my indexes are lowercase now. So far we have seen a lot of different methods. Now let's move on to the counting related methods available in Pandas series. So now counting methods come in case when you want to see overview of the data that is found in a series object of Pandas. And for this particular section we are going to use these two series. So song66 is the same as before. Now I've created a new scores_2 series with 5 different indices and 5 different values. One of them is still null. And now let's just see the count of different indices, or rather not null values in a series with the .count method. And this count method provides the count of entries, how many are unique and how many are duplicated, and this method returns the number of non-null items, as I said. And in this series we have 5 objects or 5 values present, but only 4 of them are not null, so we get 4 as our answer. Now histogram tables are very easy to generate in Pandas. So if you think of a series as an ordered mapping of index key to values, you can use something called, or a method called value counts, which returns a mapping of those values to their counts and ordered by frequency. So let's see what I mean here. So this is a histogram value. So in our series, if we see, we have 2 hundreds and 196.7 and 167.3 and 1 NaN. So it only considers non-null values, and it gives you a histogramic information where 100 is present 2 times the frequency, and 96.7 one time, and 67.3 one time as well. Now what we want to do is we want to get the unique values or the count of non-NaN items using the unique method and the n-unique method respectively. And remember that unique method will include the NaN values, and the n-unique method will not count it. So if we see them in action, we can see that okay, since 100 was present 2 times, it will give us only 4 values, and one of them is NaN. And if we do n-unique, n-unique is number unique, so we get only 3 because it does not consider the null values or the NaN values, so you get 3. Now there is a possibility that when you're working with series or data frames that you have duplicates in your data. So how do you want to deal with them? It's very simple to deal with that in Pandas. You can just call the method drop duplicates, and it will drop the duplicate values in that series or data frame. So here you see, since we had 1 duplicate value, it dropped it, and we now only have 4 values. Now there is another possibility that you want to retrieve a series with Boolean values that indicate whether its value was repeated or not, and this can be done in a duplicated method usage. So you see for all these 4 indexes it wasn't repeated, so it's false, but for Billy, as the value was repeated with similar to Paul, it said true. Now to drop duplicate index entries, so till now the drop duplicates will drop the entries where the value is duplicate, but if you want to drop duplicate indices, it certainly requires a little more effort. Now we want to create another series object, let's say this one, with 6 indices with one of them repeating, and how we can drop the indices here. So in Pandas there is a group by method available, and we can group by using the index of the series or the data frame object, and we can take the first or the last item from the values for each index label. So if we do the first fetching, we get Paul with 100, and if we do the last fetching, we'll get Paul with 79. So you can see we had 2 indices, Paul, 100 and 79. So if we pull first, we get 100. If we pull last, we get 79.